So, hello everybody, and thanks to be here. So many people here, that's great. So, I'm Cedric de Saint-Martin, and I am the lead developer of SlapOS. SlapOS is a decentralized cloud computing system. So we will see what it does and how it uses in the next 10 minutes. So first, we'll install the SlapOS package and configure the client to request instances that are in the cloud. Different types of instances. And then we will extend the cloud with this computer and request instances on this computer. So let's do it. So this is a live demo, so I hope it will work. So first, I need to install the SlapOS package. So we use the OBS Open Build System for this from source. So I just need to extend my source.list. With this command, okay, and now I just have to sudo apt-get install SlapOS.node, and here it is. So in the meantime, while it is installing, I will go to slapos.org. So this is our website. You can have your own SlapOS. This is free software. Everything is free. Everything is given. So I will just log in and so I will log in using Google, and I will go into my parameters, my account. So the network is very slow, so and I just have to ask for a token that I will just copy and try to copy. And how I have to now, so okay, so SlapOS is installed, and I have now a new command named SlapOS. And all I have to do to configure it is to run the command SlapOS configure client with my token. So it will download certificates from SlapOS.org so that now I can request instances from the command line. So we can do it from the UI, but we are developers, we are geeks, so we love the terminal, right? So SlapOS, I will request an instance of a blog, for example, of a WordPress blog. So maybe Fosdem blog, for example, and this is a WordPress instance. So it is requesting. Okay. So it shows me, so the instance is ready here, and it shows me several parameters. And I can see that one of the parameters is the URL, and I can use it to connect to my instance of WordPress. We have network, unbelievable. Okay, so this is a WordPress, classical WordPress. So let's do now something a bit different. We request an instance of a virtual machine, a KVM virtual machine. So SlapOS request. I will name it my KVM, and this is an instance of KVM. It's requesting. Oh, really quick. So again, I can see the URL what I can connect to, and I can connect to with the browser to my virtual machine using this password. Okay, ask me the password, enter it, and okay. So this is a Debian installation. It can be anything else. By default, this is Debian. Last, we will request now an instance of database, just a MySQL Postgres database. Which is of type Postgres. It's requesting again. Come on. Okay. So he's ready, and this time we connect directly to the IP. So this is an IPv6. I will directly connect using the PSQL command. Is host and user Postgres, and the secure password is insecure. So this is like demo. It happens. Yeah, so maybe we don't have IPv6 anymore here. But too bad. So let's continue. Now, so I've requested 3 instances, well, 2 instances that are on the cloud somewhere. But now I want to extend the cloud so that the instances are on this machine. It can be on any machine, it can be on a physical machine, virtual machine. And all I have to do is to run the command SlapOS node register. I will name it Fosdem machine, Fosdem machine, and I just need to say that the interface name here is Wi-Fi. So it asks me my password. Wow. So please be patient. So thanks Cisco for this. Okay, oh, nice. So we just have to be patient. So we created several different directories in the /etc for the configuration, and we can see on the bottom that it has been registered as this computer ID. All I have to do to use it now is to say that I want this computer, on this computer I want to install all that is necessary to run instances of Postgres. So this is the command supply, which we install on the library and so on. Supply Postgres, and this node. The installation again. Okay, so now I can request instances of Postgres on this computer. So let's do it and try to access it this time. So, request. So Postgres 0, and this is an instance of Postgres. But this time I will say that I want this instance not to be on the cloud somewhere, but to be here. Is the way to specify it on this computer. So it will be requested, and it will be enabled in a few minutes. So if we are lucky, we will see it in the end of the presentation. Postgres, oh yes, of course. So maybe I don't want one instance of Postgres on this machine, but maybe I want 10 instances. So it's very easy to do for I in IaaS, which is sorry? Yeah, well, this is a name, I don't care. Okay, so request, so we'll see it in a few minutes. So this is the name of the instance, so I name it like I want, and I want it to be like this. So here we quickly seen how to request instances using the command line on SlapOS. We've seen many different types of instances, how to use them, how to connect to them, and then how to extend the cloud with my own machines. So maybe to create a private cloud, so I can use for myself or for my friends or company or I don't know what, the machine as a cloud. So now what if we want to add a new software that is not yet in the list? So here we see how we will do it.
Hello? Hello? Hello everybody. I'm Viktor Horvath. For 5 years I have been working at the French company Alixen. Our main product is the collaborative Extranet Mioga 2. Now I only occasionally work on Mioga, but I was the one doing the integration with SlapOS, and I'll share my experiences with you. So Cedric showed you the user side of SlapOS, and I'll show you the developer side. First, let me tell you what Mioga is. It's a software suite for project and mission management that exists now for 14 years. It's useful for any kind of heterogeneous work groups. That means a group of people who come from different organizations or from different parts of the same large organizations. But anyway, people who don't share the same computer system, but they have to work together on a project. You could say Mioga does all the non-real-time part of a groupware. So no real-time messaging, but it tries to cater to everything else. It's a modular application with a Postgres database running typically on a server within the organization. So it's a safe alternative to externally hosted sharing sites that people might be tempted to use otherwise because they know it from private use, but which of course does not at all comply to the company policy. The license is in GPL versus 2. External contributions are always welcome. And it's our customers who decide what we at Alixen implement next. Our customers include ministries, companies, and administrations. At the heart of Mioga, you have document sharing and access through the web or through WebDAV mounts directly on your desktop. So you use a folder on your desktop with very fine access permissions for the workgroup members. So you can specify exactly who has access to what. The user base is either local or it comes from an LDAP directory. Users can have different roles in different workgroups. Now these days you take it for granted, but it's existing since 14 years. And so it's normal, of course, that in one workgroup I might be a local admin, in another I'm a user, in a third one I'm a guest, and so the fourth one I don't have any access at all. And then you have some applications written around this. With time there are more and more with client-side JavaScript and less server-side Go. There's a forum, there's news and articles, there are photo galleries, a portal, a project management, and more. Now, I say these applications are not really meant to challenge much bigger dedicated web applications, but they come in handy if you just need a little something and you happen to have a Mioga server, so you can use it. There's also a search engine, and like all Mioga applications, it will only show you the content that you are allowed to access. Now just to show you some screenshots for some recently written or overhauled applications, here you see the new workgroup management, where you can define for each workgroup which applications are accessible inside to your users, and of course you do the user management. And here's our new calendar, which blends together personal and workgroup calendars, and you can export it to the iCal format. Now, Mioga runs quite fine as it is. Why would you put such a software on the cloud, and why on SlapOS? We do it to facilitate testing. If you want to try it out, you should not need to install it on your computer. Maybe the person who's interested is not a system admin, so downloading Perl modules or CPAN modules, or just even installing operating system packages on a Linux is maybe not what he enjoys to do. So it should be possible with just some clicks to get something to give it a spin. And if you have many small instances, then an internal cloud based on SlapOS can be very efficient, because virtualization is optional, and SlapOS is designed to allow for a maximum number of instances on a single server. Finally, SlapOS has many bold design decisions. They're using directly, internally only IPv6. They are newest versions of Perl and all other software components. So Mioga usually runs on Debian stable. And by having Mioga run on SlapOS today, we anticipate the development of tomorrow's version. Now, how do you get a software running on SlapOS? There are two distinct parts. There is the compilation and there is the instantiation. The compilation makes the software and all its components available on the node. Think of it like installing shared binaries in a common location, user bin or opt or something. It can be fast if everything has already been pre-compiled, so you can install a pre-compiled package. But it can also be that if you compile everything from scratch, remember, not only the software, but also all its subcomponents, that can take a little bit of time. For Mioga, that will be Perl itself, Apache, more Perl, Postgres, and there are plenty of Perl modules and their dependencies. In this way, all versions and patches of subcomponents are under our control and independent from the rest of the system. And then on the right side, you have instantiation. An instance of the software gets created, its process gets started, and its own data lives in a partition. A partition is a distinct place. Think of it like a .application directory within your home directory. Each partition has its own Unix user, its group, and IPv6 address, and that's how they are separated from each other. The instantiation step can get repeated in order to ensure that the software works correctly. So that means instantiation must be fast in the order of some seconds, and it must be non-destructive. Of course, all user data must be kept. Both compilation and instantiation use Buildout. Buildout is a Python system that takes care of the life cycle of the software, downloading, patching, compiling, and deployment. There is reuse of code going on several levels. First of all, you have blocks of Python code, which are called recipes. And then in a Buildout profile, you have the left and right profile, I call the recipes with parameters. So the profile is like a configuration file for running Buildout. There is one top-level profile for compilation. In the end, it creates a Mioga software installation on the host. And there's an instantiation profile. When I run it once through Buildout, it creates a Mioga instance. So on the one hand, I want to reuse the recipes. On the other hand, I want to reuse components, because each component of the system is specified by a profile. And of course, I want to use existing components, and I only have to write what is not yet there, or maybe I just have to change the version. Let me show you an example from the compilation profile. Here's the profile I wrote to get mod Perl for Apache. You see the recipe used there. It's called recipe equals CMMI. CMMI stands for configure, make, install. Then I just have to give it the URL for the source code, and the MD5 checksum, so we are sure it's the right source code, and parameters for the configure step. Why do we need parameters for the configure step? Well, I want to use the components and the paths from my other components, and not from somewhere else in the system. So I have to give him the information he needs to find his dependencies. If all goes fine, if I still have network access, then I show you here the web runner. That's a little tool that you can use to test and to run your profiles. So here you see the result, and I'll just show you quickly. It's just a file hierarchy. I'll show you that we have here within Apache 2.2. We find Mokka. Now for instantiation. If I click on give me a Mioga, that will actually occupy two separate partitions. There is one for Apache and one for Postgres. That way I can build upon all nice things that already exist for Postgres. If somebody adds cluster functionality, then I can just say that I would like to have that, and then it works. The partition might be on the same node or not, as I wish. Communication happens principally through IPv6, and just for the human user, there is a front end for IPv4. I'm not showing too many details because we are a bit pressed for time, but I show you. The result is that I can see in the Slap runner what is running of my processes, and I see also the URL to connect to. That is the same as what Cedric showed you, what he sees on the command line. If I use the Slap runner for testing, I see it here in this interface. Now the issues which spent a bit of time during my development was mostly related to the Perl modules. Many of them get built in very different ways. So you have to see how it's done, where you have to enter some configuration variables. Some have hard-coded paths inside that I must extract into variables. And generally you can say that the state of IPv6 in Perl can be a bit complicated. In order to use SlapOS at maximum efficiency, I want to carefully separate the compilation part from the per instance part. So now for any further information, I want to refer you to two websites where you get all the documentations and the code for both SlapOS and Mioga. That's community.slapos.org and alixen.org. On community.slapos.org you also have a forum where we will answer your questions. And of course we will answer them now. And we will answer them now. Any questions?
So I'll just show the result of another conference. So what you saw running on his laptop also runs on my Android phone. So my Android phone is a SlapOS server. So this way, the passwords I want to keep on my hand, I keep them on my hand. So the cloud is now running directly on the phones. No more data center.
If you add a machine to SlapOS, do you automatically participate in the cloud?
The question is whether you automatically participate in the cloud if you install SlapOS.
So by default, no. When you set up some nodes, this is for you and only for you. And then you can set a list of people who can deploy things into this, or you can set it public to be paid for this.
More questions?
Will you use some virtualization or
Whether we do some virtualization?
So, no, we are bare metal. So we can request, we can deploy virtual machines, but this is software agnostic in fact. So you can deploy pretty much anything you want.
You could request a KVM and put your things inside there, but the general idea is that you run by default you run on the bare metal.
So I recommend everybody to have a look at ZeroVM. Who knows ZeroVM? Nobody knows ZeroVM? No. It's an Israeli software which is like a virtualization wrapper which only has 200 kilobytes of memory overhead. So each time you launch a Unix process, it's wrapped into kind of virtualization container, and you can start and stop immediately the process with the same kind of security containment as a virtual machine. So I think it's used for military applications. Nobody really knows ZeroVM?
Secret. I've seen a presentation of those guys.
Sorry?
I've seen a presentation of those guys in Israel.
Yeah.
They're actually doing some stuff with TypeScript as well, and this kind of patch.
So if we would rather go in the direction of ZeroVM to to do more security containment. Thank you.